We are on the next section, and you'll notice that we've skipped the order a little bit. For the textbook, we're now jumped to 6.3. I think we're coming back to 6.2 in a little bit. The first page is a bit of a wall of text, but what I would like, instead of me just reading it and going through the answers, here's what I've done is I've written all the words that should go in the blanks, and I would like you to spend a minute or two to see how many you can get right. So equivalent happens 4 times, and then these other words happen. One thing I can address right now, what's the difference between the word equivalent and the word equal? Well, if I was to say that, let's say that, right over here, let's say that 3x is equal to 6, I could say that 3x is equivalent to 6. Would you say that they're exactly the same thing? No, they're not. 3x is not the exact same as 6, but because there's an equal sign in between, they are equivalent, right? But if I was to say, let's compare my answer of 2 with your answer of 2, when we solve the question, we could say that those two answers are equal. So equal in this case, and this is not a general case we can use for all of mathematics, but in our page here, equal in this case means they're the same numbers. Equivalent means that 3x can be the same as 6. So another one, I could say 2 over 4 and 3 over 6. Those are all equivalent to 1 over 2. Is 2 over 4 the exactly same thing as 1 over 2? No, it's expressed in a slightly different way. So I could say that these are equivalent, but 1/2 and 1/2 are equal. I hope that makes sense. Yeah, I'm going to try my new fancy erasing mechanism here. Let's see if it works. So if I circle all that stuff and then erase, there we go. Okay, so I would recommend that you hit pause and then try this out. Alright, I've filled in the first 2. Let's read along here. It says, you already know that you can verify a trig identity using one of 2 methods. And to verify isn't to prove. To verify is to sort of prove for one case. One method involves graphing both sides. Try moving this around a little bit. Okay, both sides of the identity and then confirming that the 2 graphs are equivalent. The second method involves, and this is kind of the algebraic version of it, and this is to substituting. I'll see if I can move this properly. Oh, yay, crazy. Okay, let's try it again. Still learning. Okay, involves substituting one or more specific values into the expressions on both sides, and then confirming that the 2 sides are, and this is where you actually get numbers, so this would be the one where it is equal. Although identities can be verified using these methods, they are not sufficient to prove that identities are true for all cases in general. To prove a trig identity, you must algebraically show that the 2 sides are, we'll use one of our many versions of equivalent here. One option is to work on only one side of the identity, and you're going to see this in a minute, and try to algebraically make it equivalent to the other side. Alternatively, you could work on both sides of the identity and try to algebraically make the 2 sides equivalent. So you can work on either one side or you can work on both sides. If you choose to work on both sides, you need to work separately on each side. You can't, quote, do the same thing to both sides as you would in solving an equation. For example, you wouldn't multiply both sides by cosine or cross-multiply the 2 sides of an identity to prove it. At the start, you don't know the 2 sides are equal, so it's not yet an equation. If the equation on one side looks more complicated, it's usually easier to start working on that side to try to, the last one that's left, is to simplify it. Otherwise, you would have to start working on the simpler side and try to complicate it. Okay, so here is our first example to prove this identity. So we're going to try to show that this side is equivalent, the left-hand side is equivalent to the right-hand side. And we can work on one side alone, or we could work on one side at a time. Here, I think we're going to start working with the right-hand side. We could go both ways. So we're going to take the right-hand side here, and I'll just write down our initial cosecant theta minus the sine of theta. Now, to begin with, on our examples, there are these nice little bubbles here, and it says, and they don't necessarily have to be in order to follow the steps in the bubbles. You'll notice when you are solving these identities that there's more than one way to get the answer. Okay, there's more than one route. Here it says try changing everything to sine and cosine, or try something else if you have another idea. So let's try the sine and cosine idea. So my cosecant here is going to turn into 1 over the sine of theta minus the sine of theta. Okay, I'm thinking if I were to combine those two terms, I'm going to have to make a common denominator, and that's what this comment is here. You probably have to make a common denominator on the right to combine the two terms. Here I've got two terms, right? Two terms, and here I've only got one term, so I'm going to have to put these together. So if I have a common denominator of sine, so I'll go like this, sine theta over sine squared. So here what I did from this step to this step right here is I multiplied by sine over sine, right? Okay, so now I can put it over one denominator, and that would be the sine of theta. And my numerator is 1 minus sine squared theta. Okay, well that looks great. I remember now 1 minus sine squared theta, which reminds me of, and I'll just pop over to my formula sheet, that reminds me of this one over here, sine squared plus cos squared theta equals 1, because if I subtract sine squared theta from each side, I get cos squared theta. So I can go over here and say, oh, cool. So in the numerator now, I can substitute cos squared theta all over sine theta. At this point, it might be hard to say, okay, I've kind of simplified it as much as I can. What if I work a little bit on the left-hand side? So I'm allowed to do that. I could go on the left-hand side here, and I'll just switch to green just to note that I'm doing something different over here. Cos theta times cotan theta, which is going to be the same thing as cotan is the cos of theta over the sine of theta. Oh, this looks great. Now I can just multiply this out together, and I'll get cos squared theta all over sine theta. Okay, now just a little bit about the notation for proofs, because we're getting a little formal. We're trying to show that the left-hand side is equal to the right-hand side, and we've done that. So here's what we're going to do. We're going to just state very clearly that this is the left-hand side, and that on this side over here we're working with the right-hand side. And at the end we can say left-hand side is equal to the right-hand side. So we proved it. So that's basically saying there we did it. This is equal to that. Okay. Notice about some of the comments. We didn't ever say, okay, I'm going to multiply both sides of this equation, because although there is an equal sign there, don't think of this as an equation. Think of this as that we're wondering whether or not this is true. It's like a question mark. Can I make this or something equivalent to it? In this case, it was cos squared theta over sine theta, equivalent to something on the right. That's what it means to prove the identity. There, we've done it. We've proved the identity. Okay. Does the left side equal to the right side? Yes. Is your algebra correct? Did we make any mistakes? Have you used the basic identities to substitute properly? Which step in your proof allowed the two terms on the right to become one term? And the step that took place was right here when we put it under a common denominator. All right, let's take a look at the second one. Number 2, prove this identity. And you'll notice in the bubble it says here, the left side is definitely the more complicated side. Here, I think I'll just zoom in one more. It says the left-hand side is definitely the more complicated side. You should start there. You can also simplify the right a little bit. Okay, so let's look up here. I'm going to say the left-hand side is equal to, I'll just write it out here, cos theta minus 1 all over sine theta minus the tan of theta. Okay, so if I'm going to simplify this, first of all, I can simplify that tan, right? So I'll say the cos of theta minus 1 all over the sine of theta minus the sine of theta over cos of theta. Okay, now looking in the denominator, if I'm going to put that under one, if I'm going to combine these two terms, I need to multiply this by cos theta over cos theta. So my next line will look like cos theta minus 1. That's still my numerator. And here I'm going to have sine theta cos theta all over cos theta minus sine theta over cos theta. Okay, it's getting a little bit long, but we're getting there. So my next line here, I can put this denominator, keep the top the same, cos theta minus 1 all over sine theta times cos theta minus sine theta all over cos theta. Okay, something that jumps out at me here is looking at this piece right here, and I think you may have done something similar in a previous exercise, is that I can factor out a common sine theta here. So my numerator will still be cos theta minus 1 all over. Now if I factor out that sine, it'll be sine theta times cos theta minus 1, that's the bigger fraction over there, over cos theta. Now when I do my multiplying is the same thing as multiplying by the reciprocal, I'll get cos theta minus 1 times cos theta all over, now here's my sine theta times cos theta minus 1. And this is where I get the payoff, right? Because on my cos theta minus 1, I can cancel from the numerator and the denominator. So here I have cos theta over sine theta, and in the back of my mind I'm thinking, hey, that's also cotan, isn't it? So now let's look and see what we can do to the right-hand side to make it look like cos theta over sine theta. So here we have the right-hand side is equal to cosecant theta times cos theta. I'll change cosecant to 1 over sine times cos theta. Oh, and it didn't take very long, did it? Now we have cos theta over sine theta. And now we've done it, haven't we? So we've got the left-hand side. Here we can say left-hand side equals the right-hand side. Okay, there's a space for notes about the proof on the bottom, and I'd just like to say that there's definitely more than one way to do these questions. And here is, regardless of which method, okay, so first of all, more than one method. And regardless of which way you do it, you're going to have to cancel out this binomial factor, this cos theta minus 1. Cancel out a binomial. In this case, my binomial was the cos theta minus 1. It's somewhere along the way. As we go to this example number 3, I'd like you to try this one on your own. I'll end this video, and then the start of the next one will show the answer for example number 3.